My name is Kelly Paffel. I'm with Envino Engineering LLC, located in Tampa, Florida. We're an engineering firm focused on steam and condensate systems. And today I want to talk about steam system thermal cycle efficiency. One of the most critical benchmarks that we have in a steam system is for the plant to know their steam system thermal cycle efficiency. With that said, people always ask, what is steam system thermal cycle efficiency? Basically, the energy input into the boilers or boiler minus the energy losses in the system and the energy recovered back to the boiler plant. What affects the steam system thermal cycle efficiency? Boiler combustion efficiency. People always ask people, what's your steam system thermal cycle efficiency? And they will say 82%. No, that's boiler efficiency. That's not steam system thermal cycle efficiency. But anyway, boiler combustion efficiency, flue gas losses, boiler blowdown, insulation, steam leakage, flash steam losses, steam trap failures, and condensate losses. Those are the things that affect the steam system thermal cycle efficiency. Let's just talk about the steam generation operational losses. Probably one of the largest losses is the flue gases leaving the boiler operation. So right here is the flue gases coming out the boiler. And that can be attributed to 12, 14, 16% of the energy that you put in the boiler is going to be lost up into the atmosphere due to a number of reasons, which I'll discuss in other videos, but not this one. Then the boiler radiation losses, coming off of the surface areas. The combustion process itself, are we tuned to the correct fuel-air ratio of the boiler? So are we putting in more excess air than is really required for the combustion process? And the last thing is blowdown. So we have to blow the boiler down depending on the TDS or total dissolved solids in the boiler operation, and that is also a loss. And steam generation. What's not going to be in my calculations today is the mechanical energy losses. Pressure reduction done by control valves instead of steam turbines. The thing is that using a steam control valve to let down pressure is just a waste of mechanical energy. And we have all types of turbines that are out there today to do multiple purposes. So in steam generation losses, if we just take the losses is that for the boiler flue gas, we'll just say 16%. Yeah, 16.5. It's just estimated losses. Could be less, could be more, but for our example, we're just going to take that. Boiler radiation losses are done, let's say 0.5%. Continuous blowdown losses from skimming the surface of the boiler drum level, 1.5%, and boiler blowdown, the bottom blowdown, 0.2%. Total generation losses, 18.6%. Now, the boiler efficiency is done by PTC 4.1, which is really true boiler efficiency, which takes everything into consideration. Steam distribution system, uninsulated steam lines is, today we insulate everything. Everything needs to be insulated. Steam lines, valves, excess piping coming off of the system, but everything gets insulated. The other thing is steam trap station failures is another area that we have losses. And steam valves open to atmosphere. You walk into the facility all the time, and we have valves open to the atmosphere, and due to valve failure a lot of the times, but it's still a loss. And blowdown valves open to atmosphere. So they go out to blow down the drip pockets or blow down the steam lines, and they leave the valves open, and then it's another loss to the system. Now, depending on the operation and everything, it depends on how great the losses are. So the thing is that say lack of proper insulation, we'll say it's 6.4%. Steam leakage at 3.5%. Now that is estimated. That can be more or less depending on your operation. Total losses, estimated losses, we come up with 9.9%. And this is common here to see steam leakage here, like this here. So that's unfortunately it's not uncommon. And then we have the steam users, the consumers of our steam. One of the things is that we find a lot is insulation. We don't, insulate like a shell and tube heat exchanger. They do not insulate the shell. Jacketed tanks, we don't insulate the jackets. Yeah, so that becomes a factor of loss of energy. Steam leakage is out there, connection failures, flanges, other types of connections, gasket failures, and then steam trap station failures. Average failure rates 15% or higher, unfortunately, out there in the system. But the failure rate should be less than 3%. But it comes up to percentage of our losses out there in the system. So let's take a review of the end user losses. The insulation, we've already estimated that in the steam distribution, so we're not going to add another percentage for that. Steam leakage, we already did that in the steam distribution, and we're not going to add any more percentage. Steam trap station failures are estimated at 3.6% of the energy that we put into the boiler is going to be lost to atmosphere. And again, depending on the system, it could be more, it could be less. So we're saying that our total end user losses is 3.6%. And as we go through, we're going to add this up at the end and come up with our steam system thermal cycle efficiency. The condensate system, the losses out there in the condensate system, we estimate them at 3.8%. Out here, people are not returning the condensate back to the boiler plant. And remember one thing, that the condensate contains 16% of your energy. Another one that's probably right behind the flue gases of the boiler is steam venting to atmosphere, coming off of vented condensate tanks, vented flash tanks. Located down here, this is a vented condensate tank, and just venting the steam to atmosphere. It's a the size of the boiler or flue gases. It's the second largest energy loss that we have in the system. We estimated that at 7.4%, and again, depending on your system, it could be more, it could be less. Insulation, components not insulated. People don't insulate condensate tanks, condensate lines, flash tanks, condensate valves. Remember one thing, today everything gets insulated. So we're going to say loss of condensate is at 3.8%. Steam losses to atmosphere 4.4%. Insulation, again, already added underneath steam distribution loss, and we come up to 8.2%. So just a summary of the energy losses. The total losses that we estimated is 40.3%. And my thermal cycle efficiency is 59.7%. So the thing is that 40% of the energy I put into the boiler is not going to be utilized usefully. It's just losses in the system. Today, our target for steam system thermal cycle efficiency is 79.8%. So your benchmark is, what is your steam system thermal cycle efficiency? Today is a good day to get started. Tomorrow might be too late. Here's our contact information. We're here to help you out. Our approach is short-term impact, long-term impact. We want to be your partner. Have a great day.